Today we're going to do using the discriminant, all right? And the discriminant doesn't really give you answers, it just describes what roots look like. So let's say you have a quadratic equation, and this is a quadratic equation and it's in standard form. When I say standard form, I mean ax squared plus bx plus c is equal to 0. And if it's not equal to 0, then you use additive inverse to bring all your terms to one side, so it is equal to 0. So this one, already equal to 0, find the roots. How do you find the roots? Basically, they're telling you to solve for x. So you may have learned a procedure where you factor and then you use a t-chart and you get two solutions, and that's fine. Let's say you get a problem where you can't factor. It's too complicated, maybe there's a number here or these numbers don't really work together, so you use your backup plan. This guy, the quadratic formula. This will give you a solution for x no matter what, factor or not. So that's actually the way I'm going to do this one. So it was x squared minus 6x plus 9 equals 0. So understand that a is 1, b is the middle term, the negative 6, and c is positive 9. So when I use the quadratic formula, I have x equals negative 6 plus or minus the square root of negative 6 squared minus 4ac. 4 times 1 times 9, and the whole thing is all over 2 times 1. Okay, well negative 6 is positive 6 plus or minus square root of negative 6 squared is positive 36 minus 4 times 1 is 4 times 9 is 36. The whole thing is over 2. Now this works out nicely for me because 36 minus 36 is 0 and the square root of 0 is still 0. So rather than say 6 plus or minus 0 over 2, I can just put 6 over 2 because adding 0 or subtracting 0 does nothing, doesn't change anything, okay? So I don't need that part, and then I just get 6 over 2, which means my root, my answer, my solution is just 3. Only one solution. And if you've been doing this, you usually get 2 solutions. All right? So this whole thing about 0 was very important. What happens is when you have a 0 under the radical, you only get one answer. All right? So that thing under the radical, this thing here, the b squared minus 4ac, is a good predictor of what your roots are going to look like without actually finding the roots. So this thing is what I'm calling the discriminant. And that describes the roots. All right, so if you're asked to describe the roots or you want to plan ahead and see how you want to set up your graph, this will help you describe your roots without actually finding the roots. It's a little bit less work. Okay, so here's some hints on what you're looking for. If the discriminant comes out to 0, like this one did, meaning the number under the radical comes out to 0, you're only going to have one root. If the number under the radical comes out to be less than 0, meaning a negative number, then you're going to have what's called complex roots. I use the word imaginary because how could you find the square root of a negative number, right? So if whatever's under the radical is negative, that's going to be a complex or imaginary answer. You're going to have complex roots. And I should say 2 complex roots. If your answer is positive, then it's fine. You like positive numbers because you can easily find the square root of positive numbers. If your number is positive, then you're going to have 2 real roots. But if it's a positive perfect square, then that's easy. You can find the square root of something, right? So you want it to be a positive perfect square. So if it's a perfect square, then you will have 2 real roots, and they will be rational roots. If it's not a perfect square, but it's still positive, like, I don't know, 7, then if it's a non-perfect square, then you will still have 2 real roots, but they will be irrational roots. Because the square root of 7 is irrational, so it will lead to an irrational answer. All right, so these are your 4 categories. Let's run through one example and you get the idea. Let's say you're given x squared plus 2x plus 8 equals 0, and you're asked to say, or to describe the roots without actually finding the roots. So I don't need this equation here. I'm just going to use a discriminant real quick. I'm going to say my discriminant is equal to 2 squared minus 4ac. That's it, right? B squared minus 4ac. So what is that? 4 times 8 is 32. And 4 minus 32 is negative 28. So I got a negative answer, which means a negative number would go here. Don't know what the square root of a negative number is. That's less than 0 for sure. So I'm going to say, well, my roots are going to be 2 complex imaginary roots. All right, that's it. Plug it into this simple formula, describe your roots, and you're done. Thanks for watching. See ya.